Good afternoon, class. We are looking at Chapter 2, Linear, Absolute, and Quadratic Functions. Here's 2.6 Quadratic Functions. So we've covered linear functions, graphs of linear functions, modeling with linear functions, absolute value functions, complex numbers, and now quadratic functions. The objective is to graph a quadratic function using transformations, identify the vertex and axis of symmetry of a quadratic function, graph a quadratic function using its vertex, axis, and intercepts. Finding a quadratic function given its vertex and one other point, find the maximum or minimum value of a quadratic function. So reminding everybody of what we have studied, the average rate of change. Lines are in the form of a standard form ax plus by equals c, slope intercept form y equals mx plus b, point slope form y minus y1 equals m times x minus x of y. A function mx plus b is increasing when m is positive, decreasing when it's negative, constant when m is 0. And as you can see from the graph, when you connect 2 points, you get a secant line. So the average rate of change, or the difference quotient, which is delta y over delta x, is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called, and the average rate of change of y, or f of x with respect to x, over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line. This PQ is called the secant line. And there are several ways of writing it. All of this mean the same thing, class. If you look at this one as x sub 2 and x sub 1, here's the formula for that. If you look at this one, a and x, here's the formula for that. If you call this point b f of b, here's the point of that, formula for that. This distance is h, here's the formula. Please understand dq, difference quotient, they are all the same. It depends on which format you like to use. As far as complex numbers are concerned, they are in the form of a plus bi, where I by definition is square root of negative 1. I squared is negative 1. I cubed is negative I to the power of 4 is 1. A complex number also is in the form of x plus yi if you go with the complex plane, and the modulus or the magnitude is the square root of x squared plus y squared. And now 2.6 quadratic functions. A quadratic function is a function that can be written in the form of f of x equals ax squared plus bx plus c for real numbers a, b, c. A can't be 0. A quadratic function occurs in applications such as motion of a projectile, etc. Here's some examples of quadratic functions. F of x is 3x squared minus 5x plus 1. G of x is minus x squared plus 1. H of x is half of x squared plus 2/3 x. And path of a cannonball, for example, it follows a parabolic graph. A parabola that opens up when a is positive, opens down when a is negative. In this case, vertex is the low point or the minimum. In this case, vertex is the highest point or the maximum value of the function. So f of x equals ax squared when a is larger than 0. And here's your f of x. If a is larger than 1, it gets closer and closer to the y-axis. If it's between 0 and 1, it gets sluggish and gets closer to the x-axis. If it happened to be negative, it flips over. It opens down in this fashion. So f of x, ax squared plus bx plus c, the graph of every quadratic function is a parabola. It opens down or opens uh, up or opens down. The vertex is the lowest point on a parabola that opens up, or the highest point on a parabola that opens downward. That's the vertex. That's the vertex. And the x coordinate is minus b over 2a. The y coordinate you plug in. If you plug in and work it out, you get this one. You don't have to memorize that 4ac minus b squared over 4a. Just plug it in and observe. So f of x equals ax squared plus bx plus c, graph of a quadratic equation, have symmetry but a line through the vertex. This line is called the axis of symmetry. So you can fold it right here, and they cover each other. The equation of that line is x equals minus b over 2, the x coordinate of the vertex. Axis of symmetry, a line that divides a graph into two symmetrical halves. A is greater than 0, the parabola opens up. A is less than 0, the parabola opens down. X-intercepts, in general, set y equal to 0 and so on. Y-intercept takes place at x equals 0, so it's 0c. Domain, it's all real numbers. The range depends whether it opens up, down, and the location of a vertex. Here's the vertex format. Sometimes they call this one standard form, but it's better to call it a vertex format because in some texts, ax squared plus bx plus c is called standard form. So f of x is a times x minus h quantity squared plus k, is a parabola in vertex format with the vertex located at h and k. Axis of symmetry, x equals h. The parabola opens up if a is positive and down if it's negative. The larger the absolute value of a, the narrower the graph. This is the standard form. F of x is ax squared plus bx plus c is the parabola in standard form. The vertex is located at minus b over 2a, and then we plug in to find f of minus b over 2a. If we put these two together, and factor out the a, To complete the square, we need to divide this one by 2. And then we need to square that. We get b squared over 4a squared. And to undo that, you have to subtract the product of these two. That's why we have this. So this becomes a times x plus b over 2a to the power of 2. This one, if you take a common denominator of 4a squared, this one becomes 4ac minus b squared. That's how you arrive at this. But it's easy, just plug in. Okay, class? So it's better that just you plug in, it makes it easier. So again, I'm showing you how to arrive at this. But like I said, just plug in, it's just as easy. Translation or transformation of parabola. Graph the function f of x equals to x squared plus 8x plus 5. Find the vertex and the axis of symmetry. And so there are different ways of approaching it now. With this approach, as far as transformation, we are going to put these two together. So we can see the translation by putting it into vertex format. So we take the 2 out. Now this is B. Divided by 2, square it. So you need to add 4, which means you added 2 times 4, and you are going to subtract 2 times 4 to undo the process. So now you have 2 times x plus 2 quantity squared minus 3. Okay? I'm assuming everybody remembers completing this. So we start with the basic function y equals x squared. And again, the vertex is located at minus 2, negative 3 class. Okay? Axis of symmetry, because they're asking for the vertex and the axis of symmetry, x equals minus b over 2a, or simply minus 2. By the way, you could calculate it from here without going through this process, okay? It depends whether they wanted you to put it in that format or not. If they don't want it, then x equals minus b over 2a will do the job. So we start with y equals x squared. We multiply it by 2 to make it 2x squared. That means stretch it in a vertical stretch manner. So for example, this becomes 1, 2. This becomes negative 1, 2. This doesn't change. In essence, it's getting closer to the y-axis. We are going to replace the x with x plus 2. That means shift it to the left by 2 units. So we're going to move this to the left. So 0, 0 becomes negative 2, 0. Finally, shift it down by 3 units. So this negative 2, 0 becomes negative 2, 3. And here's the graph by the way of transformation, okay? Look at the vertex and axis of symmetry. Does it open up or down? And we looked at the vertex format in the previous page. We don't have to. We can take the easy way out and say x is minus b over 2a. So minus b, which is 6 over 2 times negative 3, and that makes it positive 1. So the x coordinate is minus b over 2a. By the way, if you want, so this is a, this is b, this is c. And so if I plug in 1 into this, I get the y coordinate of the vertex. So negative 3 times 1 squared plus 6 times 1 plus 1. This is 1, we get minus 3 plus 6 plus 1, which is 4. So the vertex is located at 1, comma 4. Axis of symmetry x equals 1. A is negative, it opens down. So we answered all those questions. Now, what is the effect of the discriminant b squared minus 4ac as far as the graph is concerned? The graph of f of x is ax squared plus bx plus c. So b squared minus 4ac is positive. We have two distinct x-intercepts. So you have two x-intercepts. Whether it opens up or down, it depends. If b squared minus 4ac is 0, then we have one x-intercept. One x-intercept if it opens up like that, one x-intercept. And if b squared minus 4ac happen to be negative, we don't have any x-intercepts. So it's completely above the x-axis or completely below the x-axis. Write f of x equals x squared minus 6x plus 8 in the form of f of x equals a times x minus h quantity squared plus k vertex format, and determine whether the graph opens up or down. Find the vertex, axis of symmetry, draw the graph, find the intervals of increasing, decreasing, the domain and range. So let's investigate this function with details. That's the bottom line. Now, to write it in this form, there are two ways to do that. One is just do it while they're at the same side, or you can even move the 8 and work with that. And of course, this is y. If it makes it easier, you can do that. So let's call this y equals x squared minus 6x plus 8. And let's move the 8. So work on this one by adding a number to make it to complete the square. So that means b is negative 6. Divided by 2 is negative 3. Squared is 9. So add 9 to both sides. And the right side becomes x minus 3 quantity squared. and now move the 1. Again, you didn't have to move the 1, but this is one way that in some instances may make it easier to understand. So now it's in vertex format. Whether you look at it here or here, A is 1 and it opens up. The vertex is located at 3, negative 1, and the axis of symmetry x equals 3. So right here gives you all the information that you need. We want to find the intercepts. We set this equal to 0. By the way, the y-intercept, if you go back to this, is simply 8, meaning 0, 8. The x-intercept, it's easier to set this equal to 0 and factor it into x minus 2, x minus 4, resulting in 2 and 4. So 2, 0, 4, 0, those are the x-intercepts. So if you look at this graph, this table, this is our y-intercept. 2, 2, 0 is our x-intercept. 4, 4, 0 is our x-intercept. And here's the vertex, 3 minus 1. Okay, it's pretty straightforward, everybody. Yeah. What I'd like you to see is that this is the vertex. So this distance of 3, because from 0 to 3, distance of 3. So if you go the same distance 3, you get the same y coordinate. That's the definition of axis of symmetry and what it does. So if you were to graph this by putting these points, so what points we're talking about? Here's the vertex, 3 comma negative 1. Here's the two x-intercepts, 2, 0, 4, 0. Here's the y-intercept at 0, 8. And again, look at this distance is 3. Go 3 here and you get the same y coordinate, and that's the graph. And as you look at the graph, you can see, of course, the domain is all real numbers. The range, let's just write this here. This one has coordinates 3, negative 1. So the range goes from the y coordinate of here, negative 1 to infinity. The function is decreasing here. That means from negative infinity to 3, increasing here from 3 to infinity. The range from negative 1 to infinity, domain is minus infinity to infinity. Decreasing here, negative infinity to 3, increasing the rest. Here's a function that opens down, of course, as you can see, f of x is minus x squared plus 8x. And we want to do the same thing to see whether the graph opens up or down. Right away, it opens down. Find the vertex, axis of symmetry, draw the graph, and so on. So this time, I'm not going to do completing this square. I just want to show you don't have to do that because they didn't ask. All you have to do find the vertex x equals minus b over 2a, and let me just write a is 1, b is 8, c is negative 12, x is minus b over 2a, so minus b, which is 8 over 2 times a, which is negative 1. I think I put negative 1 here, negative 1. And so 2 times negative 1 minus 2, 8 divided by minus 4, with this negative in front becomes positive. Now when we put the 4 in there, we can find the y coordinate. So negative 4 squared plus 8 times 4 minus 12. So 4 squared is 16. This makes it minus 16. Plus 32 minus 12. And it adds up to 4. So opens down because a is negative. Vertex is located at 4, comma 4. And axis of symmetry x equals 4. The y-intercept is located at 0, negative 12. At the x-intercepts, we set this equal to 0. And to do so, it's easier to factor it this way. So we multiply by negative, becomes x squared minus 8x plus 12. And we can factor it into x minus 6x minus 2. So x has two answers, 6 or 2. This means 6, 0. This means 2, 0. So let's put all of them into a table. First, this is our vertex. Now, 0, negative 12 is a y-intercept. 2, 0, and 6, 0 are the two x-intercepts. Please look at the distance of 4 from 0 to 4. If you go 4 more, you get to 8. You should have the same y coordinate. I'm showing you the effect of symmetry as far as parabola is concerned. So this one, we can make it up. So first, let's look at all those pairs. Here's the vertex at 4, 4. Here's the x-intercept of 2, 0, and 6, 0. Here's the y-intercept of 0, negative 12. So corresponding to that, we have 8 minus 12. Okay? And if you put them together, it looks like that. And again, you can see this point, okay? Of course, domain are real numbers. Range from negative infinity to the y coordinate of the vertex. Negative infinity to 4, 4 is included. The function is decreasing here. Let me put it red. So it's decreasing here. Meaning what? From 4 to infinity. And the rest of it, this is increasing from negative infinity to 4. So we know where the function is increasing, where the function is decreasing, and so on. Find a quadratic function given its vertex and 1 point. Determine the quadratic function whose vertex is 1 comma negative 5 and whose y-intercept is negative 3. So whenever we are given a vertex, we really should go with the vertex format, because then one more point will do the job. If it's not a vertex, you need 3 points, because it's f of x plus ax squared plus bx plus c. So you need 3 points to find a, b, c. But if it's a vertex, it makes life easier. So we are going to plug in the vertex. Becomes a times x minus 1 squared minus 5. We have one pair, in this case, the y-intercept as coordinates 0, comma, negative 3. So replace the x with 0 and f of x or y with negative 3. This is negative 1. Squared becomes positive 1. So a minus 5 is negative 3. A becomes 2. Plug in. This is our function. Now, we are practically done. I want you to know that if you want to expand this and write 2 times x squared minus 2x plus 1 minus 5, and this becomes 2x squared minus 4x plus 1 minus plus 2 minus 5. Let me just so plus 2 minus 5. 2 and negative 5, they add up to negative 3, and that's fine. And again, they didn't ask for the graph, but it looks something like that in case. Okay. It's pretty straightforward, everybody. We want to solve maximum and minimum problems. Note, a parabola that opens up has a minimum value at its vertex. We are referring to the y-coordinate. And a parabola that opens down has a maximum value at its vertex. So find the extrema for this function. Well, this opens down because a is negative 1, and therefore it has a max. So a is negative 1, and therefore it opens down. So I hope it's clear to everybody. X is minus b over 2a. So simply put, plug in. Minus, let's just write all of this. A is minus 1, b is 4, C is 5. So minus 4 over 2 times negative 1 or 2. That's the case, everybody. So what is the maximum value? The y-coordinate of the vertex, plug into minus 2 squared plus 4 times 2 plus 5. This is 4. This is 8. So we have minus 4 plus 8 is positive 4 and 5, positive 9. So the maximum is equal to 9 at 2, comma 9. So it's important to know the location, okay? And it's pretty straightforward. Find the minimum product of two numbers that differ by 10. What are the numbers? Well, we don't know the numbers, so we're going to call them x and y. We want to minimize the product. We're going to call it P equals xy. We want to minimize the product of x and y. Minimize P equals x times y. Knowing that they differ by 10. So you can write x minus y is 10 or y minus x is 10, makes no difference. Because ultimately you get two numbers. One of them is this, one of them is that, okay? So if you go with x minus y equals 10, that means y, take it to the other side, y is x minus 10. That's the meaning of it. P is a function of x and y. If I change the y to x minus 10, becomes a function of x. And now I'm going to call it P of x equals x squared minus 10x. This is a quadratic function. Its graph is a parabola that opens up. Graph of P of x equals x squared minus 10 of x is a parabola that opens up. The minimum occurs at its vertex x equals minus b over 2a. Again, the reason it opens up because a is 1. Let's just okay. So a is 1 and therefore it opens up. So it's pretty straightforward, everybody. Now to evaluate this, we plug in minus b, which is negative 10 over 2 times a, which is 1. And the answer is 5 because negative and negative cancel each other. So what are those numbers? X is 5. Plug it into this or to this. Y is x minus 10, either way. If you go with this, 5 minus 10 is negative 5. So one of them is 5, one of them is negative 5. Their product is negative 25. So the two numbers that differ by 10, their minimum product is negative 25. So pretty straightforward. You're going to move on. You want to find the maximum product of two numbers that add to 30. What are the numbers? So again, we don't know the numbers. How about x and y? You have to define your variables, so x and y. We want to maximize the product x times y, given that they add up to 30, x and y, x plus y is 30. If x plus y is 30, one of them you solve for y is 30 minus x. And if you look at this one, p is a function of x and y. If you replace the y with 30 minus x, you get 30x minus x squared. You put it in descending order. P of x is minus x squared plus 30x. And the reason you do it in this fashion, so you can see that a is negative 1, and therefore it opens down, everybody. Graph of P of x equals minus x squared plus 30x is a parabola that opens down. The maximum occurs at its vertex. So x equals minus b over 2a. So plug in 2 times negative 1 is negative 2, minus 30 divided by that, it's positive 15. So we find one of them to be 15. Put it in here. If they add up to 30, the other one must be 15 too. So x is 15, y is 15, the product is 225. So the maximum product of two numbers that add to 30 would be 225. That would be the maximum product, everybody. Find the quadratic function whose vertex is at 2, 5 and passes through the pair 3, 2. Again, because it's in the vertex is given, we're going to put this format, and f of x equals a times x minus h, which is 2, plus k, which is 5. And all you have to do now, use the pair that is given. 3, 2 means replace the x with 3, replace the y or f of x with 2. So let's see what happens. 3 minus 2 is 1. 1 squared is 1. So this is simply a times 1 or simply a. Plus 5 is 2. A becomes negative 3. Replace it. The function is minus 3 times x minus 3 squared plus 5. Determine the value of the maximum or the minimum without graphing. So here's the function. A is 3, it opens up, so it has a minimum. So let's find x equals minus b over 2a. So minus negative 24 divided by 2 times 3 makes it positive 4. We're going to plug in. We get 3 times 4 squared. 16. Or the 8. Minus 96 plus 53, and we get 5. The reason it's maximum, the reason it's minimum because it opens up. A is positive 3, and it opens up. Therefore, it's clear that we have the minimum equal to 5. All right, for part B, we see that it opens down. So let's just write A is negative 2, B is negative 12, C is negative 24. It opens down, so we have the maximum. But to find the maximum, let's find the x equals minus b over 2a. So that means that's actually the first step. X equals minus b over 2a. So we have minus 12 over 2 minus 2, which is minus 4. This becomes positive. This makes it negative. And then you put the negative 3 into the original function. And you evaluate it, everybody. So f of 3, we get minus 2 times negative 3 squared. This is the first one that we have to calculate, okay? Minus 12 times negative 3 minus 24. So we have 9. That's minus 18 plus 36 minus 24. And we get maximum is minus 6. Again, it's pretty straightforward. A quick recap so we know exactly what's going on. In this case, everybody, A is positive, opens up. So we have a minimum at the vertex. We evaluate x equals minus b over 2 and we plug it. In this case, A is negative, it opens down. The maximum occurs at the vertex. We calculate x equals minus b over 2a, we plug in, and we find the maximum. Example 11, without graphing, locate the vertex and axis of symmetry of the parabola defined by f of x equals 2x squared minus 3x plus 2. Does it open up or down? Obviously, A is 2 and it opens up. But in any event, let's just write, here's A, here's B, here's C, x equals minus b over 2a. We get 3 here, 4 here. So that's the x coordinate of the vertex. We plug it into f of x. And we evaluate it. This is 9 over 16 times a 2 becomes 9 over 8 minus 9 over 4 plus 2. And as you can see, the common denominator is 9 minus 9 over 4 becomes 18 over 8 plus 16. And the numerator adds up to 7. So the answer is 7 over 8. So we have the vertex at 3/4 and 7/8. Axis of symmetry, x equals 3/4. A equals 2, positive, opens up. So we have all the information for this page. And now we want to use the information from the previous example and location of intercepts to graph this. First of all, this was the vertex, axis of symmetry, okay, and so 3/4, 7/8, axis of symmetry, okay. So the information from before, A is 2, we know it opens up. Two is the y-intercept, that means 0, 2 is the y-intercept, so it opens up. So 0, 2, you don't have to do anything for the y-intercept. So we can locate that. If this is 0, 2, and look, this distance, everybody, is 3/4, right? So by symmetry, if I go 3/4 to the right of the vertex, I get the same y coordinate. Okay, so 3/4, I add 3/4, I get 6/4, or 3/2. So please understand how we got that. This distance is 3/4. Why is this distance 3/4? Because the x coordinate of the vertex is 3/4 and we go from 0 to 2. So it's another one. And right away, we do have the graph. As far as the x-intercepts, by the way, you can work it out, set it equal to 0. It doesn't have it. It opens up, and that's the vertex, and doesn't have it. So it looks like that. Domain and range. Domain is all real numbers. Range from here, 7/8 to infinity. So domain is all real numbers. Where is it increasing? The function is increasing here. The green one from 3/4 to infinity. It's decreasing here, the red one from negative infinity to 3/4. And again, obviously, there is no x-intercept, but you can work it out and you see there is no x-intercept because b squared minus 4ac is negative. Let me just remind you of that also. If you set this one equal to 0, b squared minus 4ac is minus 3 squared minus 4 times a is 2 times c is 2, and you get 9 minus 16, which is minus 7. Because b squared minus 4ac is negative, there is no real solutions. No real roots, no x-intercepts, okay? Graph f of x equals 2x squared plus 4x minus 1. Determine whether the graph opens up or down. Find the intercepts, vertex, and axis of symmetry. We've done many of these. And the only reason I chose that just to remind you of the quadratic formula. So x, so first and foremost, let's just write it here. A is 2, B is 4, C is negative 1. So it opens up, okay? Because A is 2, it opens up. X is minus B over 2A. So minus 4. 2 times 2 is also 4. We get negative 1. We want the location of a vertex. We have to plug this one in and work it out. So f of negative 1, that would be the k, if you will, h and k, or would be this, if you will. So you work it out. This is 1. So we get 2 minus 4 times million. So maybe I put it underneath. It's easier. Let me just do this. So this is minus 2. This is positive 1. We get 2 minus 4 minus 1, and that's negative 3. So the vertex is located at negative 1, negative 3. So that's the location. Negative 1, negative 3. A is 2, so it opens up. 0 minus 1 is the y-intercept. This is the axis of symmetry. X equals negative 1. f of 0 is -1, so basically this one is your y-intercept. And if I want to use the axis of symmetry class, -1, -3, 0, -1, this distance is 1. So if I go 1 to the left, here I have the same y coordinates, so -2 comma -1. Okay, so please understand. This distance is 1, so is this distance. So we go 1 to the left of the axis of symmetry becomes -2, and the y coordinate is the same. So right away, we do have the graph. However, let's find the x-intercepts. Again, this is the graph, basically, you're done. Okay, but let's look at the x-intercept by setting f of x or y equal to 0, and it can't be factored. And we are going to use the quadratic formula. Okay, first and foremost, if we have ax squared plus bx plus c equal to 0, x is minus b plus minus the square root of b squared minus 4ac over 3. So we're going to use that one. So minus b, which is 4 minus 4, square root of 4 square minus 4ac. I write 2 times 2. Now, as you can see, this is 16. This is plus 8. They add up to 24. So let's write that. And we get this one. Square root of 24 is 4 times 6, so it's 2 square root of 6. You can factor the 2 out. And we get this is an exact answer, which means minus 2 plus square root of 6 over 2 and minus 2 minus square root of 6 over 2 comma 0. So this is for the sake of graph, roughly, okay, class? But the precise answers are minus 2 minus square root of 6, which is negative 2.2, roughly 0. Minus 2 plus square root of 6, which is positive 0.22. And those are the 2 points, okay? And just so you remember that. This is x and y, okay? X and y axis. All right. Domain is all real numbers. Range from the y coordinate here, -3 to infinity. The function is decreasing here from negative infinity to the x coordinate of the vertex -1. And it's increasing over here from x coordinate -1 to infinity, x coordinate of the vertex. Let's look at one more example. We want to find the quadratic function given its vertex and 1 point. Determine the quadratic function whose vertex is -2, 3, and whose y-intercept is 1. So we are going to go with this and replace the h with -2. That means a times x plus 2 quantity squared plus 3. All right. 0, comma 1. So replace the f of x or y with 1, x with 0. 0 and 2 is 2. 2 squared is 4. You get 4a plus 3 is 1. Divide by 4. A is negative 2 over 4, or negative 1/2. Replace it. F of x becomes negative 1/2 times x plus 2 quantity squared plus 3. And of course, if you were to graph it, it will look something like this.